I made a sketch of an ellipse being created as well. In this list, it wouldn't let me put it into the picture for some reason, but this value D is the sum of these two lengths that are given, BA and CA here. So points B and C would be our foci, and then point A and also point D is going to trace around to create our ellipse. And we can see in the list here that that distance is always remaining 6 until I get out towards the edges, and then it's undefined. But we get that distance of always 6 as those 2 points trace out that ellipse. The reason why we're getting it undefined is there's, in the formula is a square root, and we end up having a square root of some negative numbers. So that's causing us a problem in the program. But otherwise, that distance is always a length of 6 to trace out that ellipse. Yes, an ellipse is kind of a special oval. Oval is a general term for kind of any oblong circle. An ellipse is a very specific kind of that. But yes, it will look like an oval.
Wait, so is elliptical like an ellipse, like we have an elliptical machine?
An elliptical machine, like the kind you exercise on, is that what you're talking about?
I was thinking of something is elliptical, but I don't know.
Yeah. An elliptical machine, your feet are following an elliptical path. So that's how the steps are moving. The planets actually go in an ellipse. The sun is the center.
Like an exact.
But each planet follows an exact elliptical path, not actually a circular path around the sun. Actually, the sun might be a focus. I took astronomy in college, and now I don't remember. It's been a long time.
Wait, so what's an eclipse? Is that related?
Different.
Okay.
Yeah. So we had this definition. Ellipse is a set of all the points so that the sum of the distances between the line and the 2 points called the foci is a constant. The singular of that is focus. So for one of them, we'll say it's a focus. If we're talking about both of those points, we'll call them the foci. Then some other key points on this graph. An ellipse can face up or down, or it can face side to side. So I'll draw this one sideways here. We're going to have a center. We're going to have our foci. Just label those with an F. Says the line through which, through the foci intersects the ellipse at 2 points called the vertices. So if I kind of connect the center and the foci all together, where those hit the edge of the ellipse, those points are called our vertices. Singular would be vertex. And that connection is called the major axis. The longer one is the major one. And if we go perpendicular to that through the center, that is going to create our co-vertices. The vertices are always the ones that are further away. So it can face up and down, or it can face side to side. The vertices are always the ones that are further out, and the co-vertices are the ones that are closer in. And then the foci will actually be inside of the ellipse. So we have a chart with all of our details. You do not need to worry about memorizing any of this chart. The equation for the ellipse is given 2 different ways, but both ways it's x squared over something plus y squared over something equals 1. A is the bigger value in this chart. Wherever that bigger value is, that's the direction it's going to face. So if the bigger value is under the x, it's going to face sideways, like an x. And if the bigger value is under the y, like our y-axis. So wherever the bigger number is located in those denominators, that's the direction it faces. So when under the x is bigger, it's horizontal. When under the y is bigger, it's vertical. And in this chart, A is always the bigger number. So our vertices are going to be in line with that longer axis. So if our graph is horizontal, the vertex should be in the A position for horizontal x. If it's vertical, then the A value would be in the y position. The co-vertices are the opposites. And then underneath, we're given an equation that describes where the foci are going to be located. So c squared equals a squared minus b squared, kind of like the Pythagorean theorem, but an important difference there that we're subtracting. And it says where C is the distance from the center to the focus. Okay, C is the distance from the center to the focus. So that will help us locate how far the foci are away from the center. And then the foci should always be in line with the vertices because they're on the major axis. So that's a lot of information, but let's jump in and see how it plays out in a problem. So the first thing we need to do is get this in standard form, and it is not right now. So in the chart, there were two different standard forms, but both are x squared over something plus y squared over something equals 1. So a big problem with this is that it is not equal to 1. So what could I do to make it equal to 1? That will also give me fractions like I need. Divide by 144. So that gives me x squared over 16 when I reduce 9 over 144. And y squared over 9 equals 1. So to draw this, for today, our center will always be the origin. Then from the origin, under the x is a 16. We are going to take the square root of that and go that far out along our x-axis. So along our x-axis, from that center, I'm going to go 4 spots and put a dot, and go back 4 spots and put a dot. Those will be our vertices.
What do we get for?
Square root of 16. I'm going to go the square root of the number under the variable.
So it's just 3 up.
So under the y is a 9, so square root is 3. So we're going to go 3 up and 3 down. And since those ones are closer in, those will be our co-vertices. And then reconnect. And that makes our ellipse. If you just asked to draw, then you would be done. But we're also asked to identify the foci. So to locate the foci, we're going to use the equation that is beneath your chart, which was c squared equals a squared minus b squared. A squared and b squared are the numbers that are in the equation, and a squared is the bigger one, so that when we do our subtraction, we'll always end up with a positive. So a squared is 16, and b squared is 9. A squared and b squared are the numbers that are in the equation. We don't need to square them again. They're already squared in the equation. And we want to subtract so that we get a positive. So c squared equals 7. We'll take a square root of that and get that c is plus or minus the square root of 7. That is how far our foci are away from the center, and they're in line with the longer axis. So this one is horizontally longer. So we're going to go the square root of 7 away from that center. Square root of 7 is between 2 and 3. So between 2 and 3, I get my foci. If it asks you to identify points, identify the foci, identify the vertices, co-vertices, just labeling in the picture is not enough. You need to actually say what the point is. So the foci are located on the x-axis plus and minus 7, and they're not up at all. So that goes in the x position, since x is the longer axis.
If you weren't drawing it, how do you know long ways or...
Wherever the bigger number is, that's the direction it faces. So since the bigger number is with the x in this one, I know it's going to be horizontal. If the bigger number is with the y, then it'll be vertical.
What did the foci do again?
The foci are the 2 points, like when I had the tape on the board, that's where the tape is.
Wait, so is plus...
Oh, yes, thank you. Plus or minus the square root of 7. This problem didn't ask for them, but some of your problems will. So if we needed to locate our vertices, the vertices are the ones that are further out. And so those would be the ones that are on the x-axis and they are out 4, up 0. And our co-vertices are the ones that are closer in. They are over nothing, up and down 3, since they're on the y-axis. Okay, so some of your questions in your homework, again, in this chapter, it's been really important to read your directions so you give everything you need and you don't end up doing more work. So some of your problems want you to identify certain points, some of them want you to graph, some of them want you to do both. So make sure you read your directions so that you do what you need to do. If it asks you to identify points, that means like not just label in the picture, but write out the point. All right, so for our second example, the first thing we need to do is get it into standard form. How do I do that? Divide by 100. So I get x squared over 25 plus y squared over 4 equals 1. To graph, be centered at the origin. Under the x is a 25. So along the x-axis, I'm going to go out 5. We just want to take the square root when we put it into the graph. And under the y is a 4. So along my y-axis, I'm going to go 2. And connect around. Then we need to find our foci. We're going to use the equation c squared equals a squared minus b squared to do that. A squared and b squared are the numbers in the equation, so that a squared is the bigger one. So that when we subtract, we'll always end up with a positive. So we get c squared is 21. And c is plus and minus the square root of 21. So if we want to label them in the picture, the square root of 21 is between 4 and 5. So our foci are pretty far out on this one, close to the vertices. The closer those foci get to the center, the more round circular it'll be. A circle is actually kind of a special case of an ellipse, where the foci are away from the center, the more oblong that ellipse is going to become. So to name those points, the foci are on the x-axis, so plus and minus square root of 21 in the x position, comma 0. And this problem didn't specifically ask for it, but some of your homework will. So we'll also label our vertices, are again on the x-axis, so that number goes in the x position. And our co-vertices are on the y-axis, so that number will go in the y position.
How did you get 5 and 2? Oh, you just
Square root of the numbers, yep.
So if the bigger number is under x, it's always going to be, the vertices are going to be positive, negative, a, 0.
Yes. Yep, if the bigger number's under the x, then the vertices will have the spot. If the bigger number's under the y, the vertex have in the y spot. And then the co-vertices are always the opposite. Okay.
Do we need to give all this stuff?
Depends on the direction. Directions, some of them ask for some ask for different things. This one wants us to write an equation. So our standard form of the equation, whether it's horizontal or vertical, is x squared over something plus y squared over something equals 1. So our job is to fill in those blanks of the somethings. We have to figure out what goes under the x and what goes under the y. we are given that this thing has vertices at one of them, a vertex at 0, 7. That 7 is in the y spot. So that should have something to do with the y in the equation. But I'm not going to put 7 into the equation.
Would be 49.
I'm going to put 49 into the equation, because in the equation everything is squared. It's y squared over, so we want it to have the vertex value squared in the equation. So we're going to square that number and put it under the y. We have a covertex with a number in the x position. So what do I do with that? Make it 36 and put it under the x. And that's our equation.
Is that it?
That's it.
Is this in standard form?
This is standard form.
No. I think you could tell.
So when we're asked to write an equation, we're going to start with that standard form of x squared over something plus y squared over something equals 1. And then our job is to fill in the somethings. We are given a vertex with a number in the x position. So under the x squared, we will put 16. And then we are given a focus, not a covertex, like the last problem. So this is in the x position again, but it can't go under the x. We already have something under the x. The vertices and the covertices are what go into the equation. The focus does not go into the equation. So what we need to do is use our focus equation, c squared equals a squared minus b squared. C is the focus value. So that 2 is C. Your vertex is your A value. If you were given a covertex, that would be the B value. Vertex is A because A is bigger and the vertices are bigger. So if you're given a covertex, that would be a B value because the covertices are the smaller. And C is always the focus. So then we get 4 equals 16 minus b squared. Subtract 16. They get negative 12 is negative b squared, which means that b squared is 12. We could find what b is, but we don't actually care, because in the equation, everything's supposed to be squared. So in that equation, we're going to put 12. We don't actually care what b is, because in the equation, we want everything to be squared. So we can just leave it at b squared is 12 and plug the 12 in. Questions? All right, so we want to write an equation. So we're going to start x squared over something plus y squared over something equals 1. We have 2 blanks to fill in. We are given a vertex with a number in the y position. So what do I do with that? Square it and put it under the y squared. We are given a covertex with a number in the x position. So likewise, we're going to square and put under the x. So if you're given your vertex and your covertex, you're really given what you need as soon as you square them. But if you're given your focus, you have a little bit more work to do. Oops. So we have x squared over something plus y squared over something equals 1. Our vertex has a number in the x position, so we're going to square it and put it with the x. But then we're given a focus also in the x position, not a covertex. That focus gives us our c value. The vertex gives us our a value. And we're going to plug into c squared equals a squared minus b squared, which is below the chart in your notes and does not need to be memorized. 3 squared equals negative 6 squared minus. So 9 equals 36 minus b squared. Subtract 36. You get negative 27 is negative b squared. So that means b squared is 27. And that's what goes in the equation. We don't need to find b because in the equation we want everything to be squared anyway. Okay. Questions? In your homework, once again, you're going to have some built-in review. So, how can I tell if it's a parabola?
One of them is squared.
One squared and not the other one. Now, a circle and an ellipse, they're both squared. So how can I tell whether it's going to be a circle or an ellipse, even if it's not in standard form? So like our very first problems today were not in standard form. They said something like 9x squared plus 16y squared equals 144. Something like that. How can I tell that that's an ellipse and not a circle?
They're going to be fractions.
No, they're both x and y are squared. It's parabola, it'd just be x squared.
But how do I know it's not a circle? Because a circle has them both squared too.
Circle is 144 with
They have numbers.
Because 144.
They have numbers in front of them, but we had in our last lesson some circles that were something like 4x squared plus 4y squared is 16.
They don't divide into
Well, all of them, they all divide evenly into that other number. What's different about the two equations?
one of them is not factors.
They're all multiples. 9 and 16 give 144. 4 and 4 give 16. They're not the same. That's the key, that the coefficients are different. Because remember, a circle is a special form of an ellipse where everything is equal, that the two radii are the same. Whereas an ellipse, we have we don't call it a radius, but we have different lengths of x and y. So if your coefficients are different, it will be an ellipse. If they are the same, it will be a circle. Okay? So that's what you're looking for to tell the difference between an ellipse and a circle. If the numbers in the front are different, it's an ellipse. If the numbers in the front are the same, it's a circle.